Once again, welcome back to the video series on Math Revision Made Meticulous. Day 25, Linear Differential Equations. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us see what is a linear differential equation. A differential equation is linear if the dependent variable y and its derivative appear only in the first degree. Y will be there and dy by dx will be there. That's all, simple. Therefore, you will have only y, the dependent variable y will be linear, that is y power 1, and its derivative also appear in the first degree. The general form, if you want to have it, it is dy by dx plus py is equal to q, where p and q are functions of x. You are identifying here that p and q are functions of pure functions of x, and the power of y is only 1 and the power of dy by dx is also 1. What is the observation we are having over here? The coefficient of dy by dx is 1. Suppose for a linear differential equation, if it is not 1, you have to make it as 1, and the power of y is 1, and there will be no other term involving y. Suppose you have any other term involving y, for example sin y, cos y, then y square, then xy square, then remember you have to search whether it is not a linear differential equation. You have to check it out for some other type of differential equation. Therefore, please remember once again, the form is dy by dx plus py is equal to q, where p and q are functions of x, and the coefficient of dy by dx should be 1, and the power of y is 1, and there is no other term involving y. You will have only functions of x apart from y. How to solve it? First, express the differential equation in the form dy by dx plus py is equal to q. What is that q? The right hand side, which is the function of x. What is p? Coefficient of y, which is a function of x, and dy by dx coefficient should be 1. After that, we can identify p and q. What is q? The right hand side function of x. What is p? The coefficient of y power 1. That's all. Then evaluate integrating factor. We have to evaluate the integrating factor, which is e power integral p dx. As p is a function of x, we can integrate it with respect to x, e power integral p dx. Then write the general solution. Y into integrating factor is equal to integral q into integrating factor into dx plus c. Now on the right hand side, that q into integrating factor will be totally a function of x only. We can integrate it with respect to x, and remember it may come under a very simple integration, or integration by substitution, or integration by parts based on the situation. Let us take a question now. Dy by dx minus y by x is equal to 2x square. Please keep it in mind, it should be dy by dx plus py is equal to q. Therefore I have to visualize it as dy by dx plus y into minus 1 by x is equal to 2x square. Don't take the coefficient of y directly as p. It should be plus py. Therefore here p is minus 1 by x and q is 2x square. Now I will go on finding the integrating factor, e power integral p dx. Therefore e power integral minus 1 by x dx, which is e power minus log x. Remember, whenever it is e power log of something, the same thing, because e and e power x and log x, they are all inverse function to each other. But here we are getting e power minus log x. Therefore identify it as e power log of 1 by x. Minus log x is log of 1 by x. Minus log sin x is log of 1 by sin x. Minus log tan x is log of 1 upon tan x. Good. Therefore the answer is 1 by x. For now I have identified the integrating factor very quickly now. Now let us move on. I have integrating factor as 1 by x, q as 2x square, which is the right hand side. Therefore the general solution is always given by y into integrating factor is integral q into integrating factor into dx plus c. Put it there, y into 1 by x, integral 2x square into integrating factor 1 by x dx plus c. X and x will get cancelled. You will get 2 into integral x dx. Once again, integral of x ds is x square by 2. We are getting cancelled. Therefore y by x is equal to x square plus c. You can leave it as it is, but suppose if you want to give the value as in terms of y, it is y is equal to x cube plus cx. But in most of the cases you can do it. You can divide the right hand side by the integrating factor. so that you will get the value in terms of y. Let us move on to the second question. dy by dx plus y into secant x is equal to tan x. Very clear here. I am able to identify what is p and what is q. P is secant x and q is tan x. I will go for integrating factor now. E power integral p dx, e power integral secant x. For e power integral secant x is log secant plus tan. Therefore, integrating factor is secant plus tan. Integrating factor is secant x plus tan x. Continue. Integrating factor is secant x plus tan x. Q is tan x. Therefore, the general solution is y into integrating factor equal to integral q into integrating factor into dx plus c. Substitute now. Y into secant x plus tan x equal integral q is tan x into secant x plus tan x dx plus c. Expand the bracket. Tan x into secant x tan x plus tan square dx plus c. Let us do the integration now. It is very simple. Integral secant x tan x, and the tan square, if you want to integrate, write it as secant square x minus 1 into dx. Now all these terms on the right hand side are directly integrable because of direct formulae. Integral secant x tan x is secant x, integral secant square x is tan x, integral of minus 1 is x. Therefore, it is y into secant x plus tan x equal secant x plus tan x minus x plus c. Now you can divide the right hand side by secant x plus tan x and give the answer, or you can leave it here itself. Let us move on to question number 3. Solve x square minus 1 dy by dx plus 2xy is equal to 1 upon x square minus 1. Don't jump into conclusion that the coefficient of y is p. Be careful. Dy by dx coefficient should be 1. I will make it as 1 by dividing the total differential equation by x square minus 1, which is the coefficient of dy by dx. For dy by dx plus 2x upon x square minus 1y equal 1 upon x square minus 1 into 1 upon x square minus 1. Very simple now. P is 2x upon x square minus 1. Q is 1 upon x square minus 1 the whole square. Now I will find the integrating factor. E power integral 2x upon x square minus 1 dx, which is e power log x square minus 1 because numerator contains the differentiation of the denominator. Therefore, integrating factor is x square minus 1. Log of e power log of x square minus 1 is x square minus 1. Now integrating factor I got it and q I have got it. Therefore, the general solution is y into integrating factor is integral q into integrating factor into dx plus c. Substitute y into x square minus 1 integral 1 upon x square minus 1 q into integrating factor x square minus 1. X square minus 1 getting cancelled, you are having a integral 1 upon x square minus 1. Please recollect the formula. Integral dx upon x square minus a square is 1 by 2a log x minus 1 by x plus 1. Therefore, it is 1 by 2 log x minus 1 by x plus 1 plus c. You can divide the right hand side by x square minus 1 and give the answer also. Let us move on to question number 4. Once again here be careful. Coefficient of dy by dx is other than 1 and the power of y is 1. Therefore, it is a linear differential equation. Let us convert it for our to the standard form. Divide the total differential equation by cos square. For dy by dx plus 1 by cos square y is equal to tan x by cos square x. 1 by cos square is secant square. Tan x by cos square is secant square into tan. I have identified what is p. I have identified what is q. P is the coefficient of y and q is the right hand side. Put it in the integrating factor e power integral p dx, integral e power secant square x dx, e power tan x. Here there is no log, therefore we have to keep it as e power tan x only. Move on to integrating factor and q we have obtained. Put it in the general solution format. Y into integrating factor is integral q into integrating factor into dx plus c. Y into integrating factor, therefore y into e power tan x is equal to tan x into secant square x, that is q, into e power tan x into dx. Now here you are seeing that differentiation of tan x is inside the integral. Well, let us now try to start the problem by means of substitution. Put t is equal to tan x, dt is equal to secant square x dx. Let us see what happens to it. Tan x is a t, secant square x dx is dt, e power tan x is e power t. Oh, we got an integral now which can be done by using integration by parts, that is polynomial and exponential. Take ust and dv as the remaining e power t dt. for du is equal to dt and v is equal to e power t. Now put it in the uv minus integral v du form. For y into e power tan x is u into v, t into e power t minus integral v du, therefore e power t into dt plus c. Now it is very simple now. The right hand side is t into e power t minus e power t plus c, because integral e power t dt is e power t only. Now what you have to do now? We have to do the resubstitution. Put wherever t comes as tan x. So the answer is y into e power tan x equal e power tan x into tan x minus e power tan x plus c. You can divide the right hand side by e power tan x. If you do it, then what will happen is y is equal to tan x minus 1 plus c. Let us move on to question number 5. It is not given in a linear differential equation format, but when I see it, I am seeing that the power of y is 1. Well, let us try to convert it into linear differential equation format. For that, I am splitting the right hand side, x upon the denominator minus 1 upon the denominator. Let us bring that minus of y cos x by 1 plus sin x to the left hand side. It will become dy by dx plus cos x by 1 plus sin x y is equal to x upon 1 plus sin x. Here I have identified the coefficient of y as p, the right hand side as q. Good. It is a linear differential equation. Therefore, integrating factor e power integral p dx, that is e power integral cos x by 1 plus sin x dx. Now the numerator contains the differentiation of the denominator, so it is log of the denominator, log of 1 plus sin x. Therefore, 1 plus sin x is the answer. Now we have obtained integrating factor. We are having the value of q. Let us continue. The general solution is given by y into integrating factor is equal to q into integrating factor into dx plus c. Therefore, y into 1 plus sin x plus is equal to integral x upon 1 plus sin x into 1 plus sin x dx. 1 plus sin x getting cancelled. Only integral x dx, which is nothing but x square by 2 plus c. Now we can divide the right hand side by 1 plus sin x. I can give the y as the answer. Well, success is dependent on effort. All the best. Thank you.